When numbers overwhelm and even appear chaotic, the science of statistics steps in and brings out the patterns hidden behind this seemingly random world of people and events. We use ideas of statistics in our daily lives without being conscious of it, such as sampling. Likewise, we know that variability is part of nature. One leaf is not the same as the other. Variability is also inherent in our actions, such as measurement. Statistics provides a framework for such intuitive ideas and enables us to derive quantitative information and choose a particular course of action. The analytic basis of statistics, namely probability theory, traces its origins in games of chance and gambling in the 16th century that culminated in Galton's technique of linear regression to study correlations and the works of Laplace and Gauss on measurement errors in the 19th century. Historically, statistics has been part of statecraft because information or data about people and their activities is key to governance. Today, besides affairs of state, use of statistics has permeated virtually every human endeavor in research, pattern recognition, anthropology, genetics, voice analysis, software reliability, cryptography, manufacturing and quality control, weather forecasting, financial markets, and the social sciences. And the man who made this happen in India was Chandra Mahalanobis. When Mahalanobis arrived on the scene around 1920, it was an era of important developments in statistics. Around 1900, Carl Pearson had developed techniques for testing hypotheses against experimental data. A year later, he also founded the journal Biometrica, exclusively devoted to biology-related statistical studies, which triggered the growth of statistics as a new science that could be applied to diverse fields. In the following years, the scope of statistics expanded and began to deal with real-life problems. The renowned British statistician Ronald A. Fisher invented the techniques of sampling and experimental designs, which he applied to problems of agriculture and genetics. Around this period in India, barring isolated efforts and routine collection of data by the British administration, use of statistics was at best rudimentary. This picture changed dramatically with Mahalanobis' entry into statistics. His pioneering efforts and vision soon placed India at the forefront of statistics in the whole world. Mahalanobis, or the professor as he was known, was essentially a Renaissance man. His egalitarian, social, cultural and scientific worldview was characteristic of other important figures of the 19th and early 20th century Bengal.
I must remember in gratitude what I owe to Rabindranath Tagore, who had a view of human civilization as unity in diversity of international culture, which he had got as a heritage from Ram Mohan Roy, and which, if I may say so, he has passed on as a heritage to our Prime Minister Jawaharlal Nehru.
He was a visionary in the mold of Shah, Raman, Bose and Bhabha, who dreamt of building a self-reliant and modern India using science and technology. Mahalanobis was born on June 29, 1893 into a progressive, well-to-do family. After graduating with honours in physics from Presidency College, Kolkata in 1912, he went to England in 1913 and completed his tripos in mathematics and physics in 1915 from King's College, Cambridge, and was due to do research in physics at the Cavendish Laboratory. Before beginning his research work, he returned to India for a brief vacation. But he could not go back. First the war intervened, and then his personal life. He also found a job at the Presidency College as a physics teacher. It was quite by chance that Mahalanobis was introduced to statistics. Just before he left Cambridge, while browsing in the King's College library, his tutor drew his attention to the volumes of Biometrica. Mahalanobis was drawn to this new science by instinct. He found the articles so engaging that he bought all the available volumes and studied them as he sailed home. And this changed the course of his life forever, from a potential physicist to becoming one of the foremost statisticians of the world and the father of the statistical movement in India. It is anyone's guess how statistical science in India would have evolved if Mahalanobis had pursued a career in physics. Indeed, considering the galaxy of outstanding statisticians of Mahalanobis' heritage who have made seminal contributions to statistical science, the field itself may have developed differently. For Mahalanobis, statistics was not a narrow subject confined to theory of probability or analysis of data in research or routine collection of data for administrative purposes. It was a science rooted in real-life applications. His entire body of work in statistics grew from this perspective.
He emphasized the fact that all data collected must have some focus, and because that's the only way you can generate relevant data to solve a particular problem. So he said, although statistics is used for planning, you must have a plan for collection of statistics also. So that's I call Mahalanobis' dictum.
Mahalanobis devoted his entire academic life in the intensive development of statistics in India.
I know I am lacking in the ability of a great pioneering scientist. All I can claim is the desire to work with seriousness and complete integrity of purpose, not shirking the pedestrian, detailed work or unpleasant tasks.
His contributions of striking originality spanned as diverse disciplines as anthropology and flood research. Each one of his contributions is a continuing story, and all subsequent growth of statistics in the country can be traced to his broad vision for the development of the subject. It is no coincidence, therefore, that 50 years of his life in statistics is known as the golden era of Indian statistics. Mahalanobis' first opportunity to turn his interest in statistics to work came in 1917 when Acharya Brojendranath Sheel, the then Calcutta University professor of philosophy, asked him to help in the work of the University Examination Committee. Mahalanobis used statistical methods to analyze the examination results. In 1920, at the Nagpur session of the Indian Science Congress, Mahalanobis happened to meet Thomas Nelson Annandale, the then director of Zoological and Anthropological Survey of India. This led to a statistical study of Annandale's anthropometric data on a group of Anglo-Indians in Calcutta, which resulted in Mahalanobis' first paper. In 1927, during a brief visit to Carl Pearson's laboratory in London, Mahalanobis found that the coefficient of racial likeness, a measure that Pearson had devised to study similarities between groups, was flawed because it failed to account for correlations, say between height and weight. This led Mahalanobis to invent his famous d-squared statistic, now known as the Mahalanobis distance in statistics literature. This seminal paper was published in 1930 in the Journal and Proceedings of the Asiatic Society of Bengal. Not surprisingly, Pearson had rejected the paper which Mahalanobis had submitted earlier to Biometrica. Widely used in a variety of applications, Mahalanobis distance is a measure of affinity between two populations, say of castes or tribes, plant taxa, geological strata, ethnic groups, and engineering goods. The d-squared statistic was applied in the major anthropometric surveys of the United Provinces and of Bengal during the 1940s.
When Cambridge University acquired some material on some skeletons which were dug from ancient graves in Africa and brought to the museum for study. Now they didn't know how to analyze the data. So they sent a telegram to Mahalanobis, can you send somebody who can apply Mahalanobis distance on the data? So Mahalanobis chose me. So I went and worked for 2 years in the Anthropological Museum in Cambridge and did statistical analysis on the skeletons they brought from Africa. The skeletons were about 800 to 1,000-year-old skeletons.
Mahalanobis' anthropometric studies and the distance concept opened up a rich field of research. Many theoretical properties of D-square were obtained by R.C. Bose, S.N. Roy and C.R. Rao.
It's one of the best theoretical objects that have been studied endlessly after that, and it also gives rise to methodologies like classification, for example. Pattern recognition is a classification, and one of the first pioneering attempts were done at ISI using Mahalanobis D-square.
Even if Mahalanobis had done nothing else, his name would have made it to the annals of statistics. Mahalanobis had an uncanny sense of figures and could detect errors easily. In 2 classic publications, he reconstructed a large series of anthropometric measurements published by Risley, which had been condemned as flawed. Indeed, as a physicist, Mahalanobis attached great importance to errors in observations, random, systematic, investigator bias and mistakes in recording, and many of his important contributions arise from considerations of measurement errors, particularly in agricultural experiments and sample surveys. This brought him in contact with Fisher in 1926, who later helped Mahalanobis to get the British government implement many of his statistical ideas in the field. This relationship became a lasting friendship until Fisher's death in 1962. It would have been a strange sight in the 1930s and 40s to see a man in a hat accompanied by others with some device moving from one plot to another in the fields of Bengal and Bihar. This was none other than Mahalanobis, who carried out some pioneering sample surveys for crop estimates.
His main interest in sample surveys came from the influence that he had from Habak. Habak was a civil servant in the eastern India, and he found that the data collection was not at all good. So he thought of introducing something called random sampling cuts in the agricultural fields. Mahalanobis borrowed this idea from him, and he himself started trying out various experiments in the fields to collect data on various standing crops. And I think this led him to start on a small scale to find the jute acreage in Bengal at that time. And then he went on expanding this to the whole area.
A statistical survey for Mahalanobis was like a scientific experiment, and planning for it required the same rigor and discipline.
He equated collection of data in large-scale sample surveys to statistical engineering. This was perhaps the philosophy behind his teachings of statistics as a key technology. His approach to sample surveys also is that you just cannot have a variance function and then minimize that, or a cost function and then minimize that, and so on, but you should take everything into account. The whole system, the investigator, the collection of data, the instructions given to the investigators, the operations in the field, the possible non-sampling errors and things of that type.
He therefore used different instruments, different observers and different sets of measurement conditions for the same sample to minimize instrument errors and investigator bias. He developed inbuilt repeat sampling methods for cross-validation of data like interpenetrating subsamples.
That means you have a big population and from which you want to draw samples. Instead of just sending one investigator or one group of investigators, he divided the whole thing into subsamples, independent subsamples. And these are interpreting in the sense that the same whole sample which is divided at random into various subgroups, and each subgroup given to one set of investigators. So that at the time of collection of data, you can see if there is any difference. If suppose one investigator quotes a figure which is double the other investigators, immediately in the field you can check whether there is something wrong with the figure.
Even today, the NSS has no design-based estimates. They still use the interpenetrating sample, so it's almost essential. But it was only used in that context till the bootstrap came, and the bootstrap almost revolutionized statistics.
In the 1930s, Sir John Russell's report on the Imperial Council for Agricultural Research had strongly supported Mahalanobis' proposal to carry out sample surveys for crop estimates. Beginning 1937 and lasting for nearly 5 years, he carried out a survey of the Bengal jute crop that is now a landmark in the world of statistics for the innovative techniques adopted.
He was interested in trying to look at what the structure is like, so he introduced the pilot surveys. So in fact his pilot surveys which he did, that is, you take a very small part of the population and then go there and then check and get an idea about the variability, about the cost, about the time it takes, how much time it takes to canvass a schedule. So this is a pilot survey, and he kept on developing based on this. In fact, this is what we all know that Abraham Wald acknowledges in his sequential analysis. Sequentially you do this. And another interesting thing we could say that he always insisted on the cost aspects, which was perhaps ignored by Neyman and others.
One of the most important surveys undertaken during the 1940s was the one on the after effects of the Bengal famine of 1943.
The famine survey is not the first one that ISI did. There were before that two very important surveys we did. One was on the Calcutta survey, we called it, on the cost of living in Calcutta. Another was the Jagaddal workers, jute workers survey. And both of them had very important policy implications, and both were based on technique of sample survey. The famine survey actually came after that on a larger scale. Now that the Jodha is a social phenomenon became known. That was one of the findings of ours. Second finding was that people appeared to be abject to poverty. This was the first time that in Bengal women came out in the field to work. Third thing we found is that during the accumulation of grains, a new class has developed who have urban access, those who had black money. From this time on, black money was institutionalized.
But there was resistance from the proponents of complete enumeration. After nearly 12 years of controversy, in 1948, sample surveys were adopted as the basis for official estimates, as they were found to be more efficient, reliable, quicker and cheaper in comparison.
Previously, we used to do everything by hand tabulation, then computation, etc. When you had these masses of data from famine, officers said that Ramakrishna, you can't do it. We better get something mechanical to get it done. And that is how the first machine tabulations, computation came to India through the famine survey.
The Indian Statistical Institute, from the very start, it was trying to use the most advanced form of computational tools for all purposes. Since that was since 30s, since the formation of the institute, Mahalanobis saw that the best type of facet type computing machine was in the institute. Then he was the first to bring in the punch-card machines for doing statistical data analysis.
The first computer that was institute attempted was a electronic valve based machine, and then professor wanted to get a modern machine. So professor asked Somamitra to try his hand on a transistor, and Somamitra collaborated with Jadavpur University, and then but the machine was installed in Jadavpur University, and so that was the ECJU, ISI Jadavpur University combined joint project.
In my view, it's the Mahalanobis and Homi Bhabha are the pioneers of the Indian information technology research. Professor Bhabha looked at it from the point of view of physics and the other things, and Mahalanobis looked at it from the point of view of large-scale data analysis.
In 1922, Mahalanobis undertook a statistical study of rainfall and floods over 50 years in North Bengal and argued against the engineering wisdom of a proposal to build expensive retarding basins to control floods. Similarly, after a severe flood in the Brahmani River in 1926, Mahalanobis made a statistical analysis to solve the problem of floods in Orissa and advised the construction of a dam in the upper reaches.
What Mahalanobis did was to make a statistical analysis of the occurrence of these events so that he can compute the probabilities of various things that can happen in the future. Now, on the basis of that, you come out with some kind of solution.
He also gave the first calculations of a multi-purpose scheme for Mahanadi River, which formed the basis of the Hirakud hydroelectric project much later.
So this is a new kind of problem where different alternatives exist. Then how do you choose the best possible alternative? And this is nowadays called operations research.
But Mahalanobis had pioneered such work long before even the term had been coined during wartime studies. Even during his last years, he continued to provide new ideas and new tools for statistical analysis. He developed what is known as fractal graphical analysis, a technique to compare two different sets of data taken in two different places or at two different times. For him, as a scientist philosopher, even the applied science of statistics pose philosophical questions such as what is randomness? What is the representativeness of a sample? These remain challenging questions even today.
Four, three, 2, 1, 0.
Wondering what a rocket launch is doing in a film on statistics? Statistics lies at the heart of reliable satellite launching missions. And today, such cutting-edge applications are emerging from the Indian Statistical Institute, or ISI, that Mahalanobis founded in 1931. The ISI is the most essential part of the foundation that Mahalanobis established in the country decades ago. It remains a major world center for statistics education and research to this day. The origins of ISI go back to the early 1920s when a small group of persons interested in statistics had gathered around Mahalanobis and begun working in his room in the Baker Laboratories in Presidency College. This later came to be known as the Statistical Laboratory. Working late into nights, Mahalanobis and his young band of researchers had carried out the early work on biometry, anthropometry, meteorology and flood control here. For most, Baker Lab became their home.
We were the first to conduct tea drinking habits of the people. That is a project given by the tea board. And the radio wanted what is the preference for music of the people, so public preference survey. So we used to take part in such activities, and of course the national sample survey started. That gave a lot of opportunities for students to go and do actual field work.
December 17, 1931 marks a watershed in the history of statistical movement in India when Mahalanobis and other like-minded academics adopted a resolution to establish the Indian Statistical Institute. It was registered on April 28, 1932 as a non-profit learned society, and around 1948 it moved to its present campus in Boranagar. For the growing research output, Mahalanobis also conceived of a publication avenue in the form of a journal, Sankhya, in 1933, which is being published by ISI since then. Even today, it is one of the leading statistics journals of the world. Mahalanobis also started the first ever Department of Statistics at Calcutta University in 1941, which influenced similar efforts in other universities of the country.
We were pioneers in the sense that we set the pattern for statistical education. And education in India in statistics is very balanced. We have a good deal of statistical theory and also applications. But it's not so in other countries. They specialize in particular aspects only.
Though statistics had begun to get recognition from the government, the scientific community did not do so immediately. Despite repeated appeals by Mahalanobis, it was only in 1945 that the Indian Science Congress introduced an entirely separate section for statistics. Mahalanobis perceived statistics as an investigation tool in all scientific disciplines. Accordingly, the 1950s also saw a rapid diversification of the Institute's activities to include several branches of science with emphasis on interdisciplinary research. Many new methodologies and interesting discoveries were made in the following years, of which the most notable was the discovery of a dinosaur fossil in India. The unique experiment at the ISI in the 1940s and 50s attracted top international scientists and economists. For instance, the famous British scientist J.B.S. Haldane and his wife Helen Spurway migrated to India and joined the institute in 1957. Perhaps more than any other scientist in India, Mahalanobis was a true scientific ambassador. In the following years, another landmark was reached.
In 1959, Jawaharlal Nehru moved a bill in the Parliament declaring the Indian Statistical Institute as an institute of national importance and empowering it to award degrees in statistics. The statisticians produced at the Indian Statistical Institute with a good training in statistical theory and practice were in great demand all over the world. As a matter of fact, in the 50s, 50% of all active statisticians were Indians.
The bill also mandated the institute to carry out tasks for the government for national development. An important area where the science is at work in the Indian context is the large-scale sample surveys. Down to earth but extremely complex and arduous and rooted in the social economy of the country. Large-scale sample survey is undoubtedly Mahalanobis' greatest contribution to the application of statistics. He regarded this so vital to the country's development that he institutionalized it after years of persistent effort.
Nehru was all the time certainly one person who stood by Mahalanobis and with open mind and continued to support him. C.D. Deshmukh was another person.
In 1950, he set up the National Sample Survey as an independent agency under ISI, which was taken over by the government in 1970. In 1972, it was established as a separate organization called the National Sample Survey Organization or NSSO, a major arm of the Indian official statistical system. Mahalanobis had originally conceived sample surveys as an integral component of ISI activity so that ISI could provide the necessary technical support. ISI carried out the first round of survey between October 1950 and March 1951 under Mahalanobis' supervision, and Mahalanobis wrote the detailed report himself. The first nationwide survey was hailed as a major development across the world. The unique experiment attracted not only top statisticians but also political leaders of the world. The scale of operations was unprecedented, something that even developed countries had not attempted. The Indian experience and the methodologies adopted soon became the role model for many developing countries. As the chairman of the UN Subcommission on Statistical Sampling between 1947 and 1951, Mahalanobis advocated the use of his sampling techniques which the subcommission recommended for adopting in all parts of the world.
Actually, Chow En-lai, when he visited the Indian Statistical Institute, he was so much impressed. He said he wanted to send some students to Indian Statistical Institute for training, and he actually sent 3 of them.
As the Honorary Statistical Advisor to the Government of India between 1949 and 1972, he also guided the establishment of the Central Statistical Organization, or the CSO, in 1959 as the apex body to coordinate the statistical activities of the government.
And he was also responsible for creating statistical bureaus in every state and statistical offices in every district, so that the data collected at the source, like the villages, they go through a statistical office in the district, then to the State Statistical Bureau, and ultimately to the Central Statistical Organization.
To achieve the desired objective in any activity, planning is essential. Mahalanobis believed that data alone must form the basis of a particular course of action, and he viewed the macroeconomic issues and national development with an operations research perspective. In the late 1940s, Mahalanobis became closely associated with national planning activities. Indeed, his principal objective in establishing the national statistical system was to close the existing gaps in national income and national resource data, and also generate other socio-economic data for development planning needs. The Planning Commission had been constituted in 1950, and the ISI set up the Perspective Planning Division in Delhi to assist the national planning process. On March 17, 1955, Mahalanobis submitted to the government a draft plan frame, which was accepted as the basis for the second five-year plan. Not being a trained economist, his approach to planning was unconventional and original, but with the vision of building a self-reliant economy.
His notion of planning was basically associated with the idea of transforming the production structure in the economy. It was the assumption that if you have to meet your social objectives, whether it is employment generation, raising the national income, reducing poverty and so on, then you needed to alter the production structure from what India inherited at the time of independence from the colonial pattern of division of labor. Now, for that kind of a transformation of the production structure, he saw planning as a mechanism.
He said, sophisticated economic theories, which may be appropriate for advanced countries, have acted for a long time as thought barrier to economic progress in India. Indeed, his approach did not follow the tenets of established economic theory. The physicist in him prompted him to develop some simple mathematical models to isolate important sectors of the economy and study their interdependence.
He had to find out how much should be invested in different sectors in order to maximize the yield.
To achieve doubling of the national income and substantially reduce unemployment over a period of 20 years, he devised what are called Mahalanobis 2 and 4 sector models. In the simpler two-sector model, the entire net output of the economy was assumed to arise from two sectors, one producing all investment or capital goods and the other all consumer goods. Based on this, he argued in favor of increasing allocation of investment in the capital goods industries. In the draft plan frame, Mahalanobis had analyzed the statistical data in the framework of these models. Greater use of machinery means wheels of productivity would move faster, so his plan frame recommended a rapid expansion of steel industry.
He showed that even if you want to increase food grain production, you have to start with basic heavy industries. Indian model was very much appreciated and taken by Korea, Vietnam and other countries, starting with the heavy industries.
Mahalanobis' approach to economic planning was being criticized for not giving importance to external trade. But increasing the competitiveness of Indian industry globally was very much part of his nation-building perspective.
He was also involved in the statistical quality control movement in India. This is to increase the export potential of goods produced in India.
He had brought Walter Shewhart, one of the originators of the SQC concept, to India as far back as in 1948 to propagate SQC techniques.
If you want to produce a product which involves the combination of several elements, say several chemicals and so on. So what's the best combination of various ingredients which would give the best possible product? So that needs experimentation.
Early 70s or late 60s, we had a lot of problems with the Rourkela steel plant, as you know, because that was quite sophisticated at that time, producing flat steel, which went into electrical industry, very many uses, which needed high quality. So I was delighted when once the ISI approached me saying that they are going to introduce statistical quality control in a large measure in Indian industry. At that stage, if you remember, all our major industries have already taken off. There was textile, there was fertilizer, or steel, and so many other industries, and a vast amount of data was being generated. So that was the right time in the field for statistical quality control, the total quality control, to be introduced.
That beginning has today evolved to include frontier research areas that use statistical concepts and tools, given a new direction to ISI and a new face to the statistical movement in the country.
I have firm faith in the need of science in its most comprehensive sense to give an ever-deepening wisdom to make the right choice, to accept the right priorities in our efforts and endeavors for economic and national development.